some 900 million miles from the Sun, in the outer reaches of our solar system, orbiting the planet Saturn, lies a mysterious world. Enceladus is enveloped in ice. Because nearly all of the sunlight that manages to hit its surface is reflected back into space, it's one of the brightest objects in the solar system. At its equator, the temperature is minus 315 degrees Fahrenheit. But at the poles, the temperature is at least 15 degrees warmer, and as much as 65 degrees warmer in grooves that stretch across the south like tiger stripes. In 2005, the Cassini spacecraft spotted a complex plume of water vapor shooting out into space from several locations near the South Pole. That may mean that Enceladus harbors a remarkable secret below its frigid surface. A liquid ocean, and maybe some forms of life. This discovery was the culmination of a search that began over 3 decades ago. Back in 1979, the outer planets of the solar system lined up in such a way that mission planners were able to dispatch the Voyager spacecraft to fly past each of them. The 2 Voyagers sent back tens of thousands of images of planetary realms more diverse than anyone had imagined. The Voyagers disclosed new details about their magnetic fields, atmospheres, their ring systems, and even the very nature of their inner cores. Voyager turned up some surprising new mysteries too. A huge dark spot, a storm in fact, on Neptune. They found that Uranus is tipped 90 degrees to one side. That Saturn is less dense than water. And that you'd need the mass of 3 Saturns to make just one Jupiter. But what really knocked the scientists' socks off were the moons that orbit these gas giants. All of them have been pummeled over the millennia by wayward asteroids and comets. But a few appear to also be sculpted by forces below their icy surfaces. Neptune's largest moon, Triton, has few craters. It's marked with circular depressions, bound by rugged ridges that may mean the icy surface is collapsing. There are also grooves and folds in the land that stretch for dozens of miles, a sign of fracturing and deforming. Triton has geysers too, but these are not spurts of water. On frigid Triton, so far from the Sun, the liquid that spouts some 5 miles above the planet is nitrogen. No one yet knows exactly what drives them. Tiny Miranda, one of 27 known moons that orbit Uranus, wears a jumbled skin that's been shaped and reshaped. Most likely, its outer crust is slipping and sliding around on a molten core. The moon called Io, orbiting perilously close to giant Jupiter, is literally turning itself inside out. Rivers of sulfurous lava roll down from open volcanic cones that are constantly erupting. What was causing these moons to generate so much energy from within? The answer may well be here, on Jupiter's Europa, just slightly smaller than Earth's moon. Voyager saw no signs of volcanic activity, but instead documented a complex network of crisscrossing grooves and ridges. In the 1990s, the Galileo spacecraft was sent back to get a closer look at Europa and its sister moons. It found that Europa's surface is a crazy quilt of fractured plates, cliff faces and gullies, amid long grooves like a network of superhighways. How did Europa get like this? Well, as it orbits around Jupiter in a nearly circular ellipse, the massive planet's gravity constantly tugs at Europa's rocky core. The friction of rock rubbing on rock causes that core to heat up. That heat rises up through an ocean of liquid salty water, cracking and spreading the icy surface in 1,000 different ways. Callisto and Ganymede too also show such surface features, suggesting they have, or perhaps once had, salty oceans below their surfaces too. Crossing outward to the Saturn system, Voyager's images showed that Saturn's moon Enceladus had a similar surface. And the same was presumed of Saturn's by far largest moon, Titan, enshrouded in heavy clouds. So, when the Cassini spacecraft arrived in 2004 to scrutinize the kingdom of Saturn, it came equipped to answer a range of burning questions. Can such moons really have liquid oceans beneath their surfaces? And do those oceans have the ability to cook up and then support life? After a year in orbit, Cassini let go of its traveling companion, the Huygens probe, and sent it parachuting down towards the surface of Titan, the largest moon in the solar system. Larger in size, in fact, than the planet Mercury, and massive enough to hold an atmosphere. Unexpected winds buffeted Huygens' parachute, but the probe was able to snatch a wealth of revealing information from the air. During its descent, Huygens' onboard radar showed a complex topography, with ridges, rivers, and lakes, and even individual rocks on the ground. Titan's atmosphere is thick and cold, the thermometer hovering just above -300 Fahrenheit. Like Earth, the air here is mostly nitrogen gas. And like Earth in our very early years, Titan's muddy, wet terrain is a stew of organic compounds. But while the liquid that cycles from ice to steam here on Earth is water, Titan's ever-changing fluid is methane. On Titan, methane gurgles up from the ground in liquid form and flows into lakes. It freezes into hydrocarbon icebergs, and it puffs off as gas in orange clouds and pinkish fog. And it may not be completely crazy to imagine some form of life arising out of this chaotic, cold, carbon-rich chemistry. Once again, the evidence points toward a moon with a rocky core, heated by tidal gravity of a massive planet, and layers of liquid and ice near the surface that burst forth in cold volcanoes and icy geysers. All of this activity has left a profound imprint upon the landscape. Repeated radar passes by Cassini reveal extensive dune fields of methane mud, wetlands, volcanic vents, and the occasional crater. And there's at least one continent, now known as Xanadu. To reach us, these images had to travel nearly 1 billion miles. At the end of their journey, they were picked up by the Deep Space Network. You can think of the DSN as an early prototype for an interplanetary internet. Within just a few years, Cassini had transmitted one of the most impressive photographic records of all time, of a fascinating ringed planet, a turbulent gas giant. It saw a storm that raged across Saturn's southern hemisphere for months, generating lightning strikes thousands of times more powerful than those on Earth. Cassini witnessed a giant cyclone spinning around the South Pole of Saturn. A huge hurricane with an eye so big you could drop the entire continental United States into it without touching the cloud walls. And Cassini radioed back unprecedented new details of Saturn's most famous feature, its rings. The Italian astronomer Galileo Galilei discovered these broad, flat, concentric bands of ice and dust 400 years ago in 1610. But he couldn't see them very clearly, and he didn't realize they were actually rings. And he couldn't have had any clue how intricate they truly are. Today, we don't yet know just where they came from, nor how old or young they actually are. The chunks and particles range from boulders the size of houses down to tiny granules finer than baby powder. They may contain the remains of two moons that collided and shattered. The rings stretch more than 150,000 miles across, but they're less than a mile from top to bottom. Saturn is almost like a solar system unto itself. Everything acts upon everything else. The planet's moons, more than 60 have been named so far, and countless smaller moonlets pull and tug on the ring particles, shaping and twisting and clearing lanes, making them dance to the combined music of their masses. The medium-sized moon, Mimas, orbiting close into Saturn, has hollowed out a large gap in the rings called the Cassini division. Some tiny moons actually ride within the rings, gently shepherding the granules by gravity. And across the ring plane, spokes of different colored dust occasionally cling like strands of hair on a cold, dry day. Like the rings, each of Saturn's 60-plus moons tells a different story, enticing us in for a closer look. There's dense little Dione, hard rock covered by ice, pummeled on one side by asteroids, causing craggy cliffs to spring up on the other. Hyperion looks like a sponge, an odd-shaped world pocked with odd-shaped craters. It tumbles around so chaotically, it's really tough to predict its exact orbit. Iapetus looks like a cosmic yin-yang symbol, with one hemisphere brighter than snow, and the other darker than tar. A strange ridge system of mountains, like the spine of a rhinoceros, runs around its equator, in places more than 12 miles tall. But it's one of Saturn's smallest moons, Enceladus, that really steals the show. That's Saturn's second largest moon, Rhea, passing behind it. Compared to many of its sister moons, Enceladus sports few craters, and the largest is relatively small, only 22 miles across. Like Europa, Enceladus has a finely textured landscape, with at least 5 different kinds of terrain, a sign that it's frequently remade by geologic activity. Its fractured and wrinkled surface is most obvious around its south pole. But there's something else going on down here among these ridges. Enceladus lies outside of Saturn's bright inner rings, in the wide and diffuse E-ring. With Cassini's camera pointed at just the right angle to the Sun, Saturn's E-ring lit up. Enceladus is the bright object in the center of the frame. What is all this hazy stuff made of? Could it be coming from the moon itself? The plan had been to let Cassini tour the Saturn system until the middle of 2008. But the mission was clearly too successful and too intriguing to let it end. And the Cassini science team suspected they were onto something big. So they went to work, plotting new orbital paths, building a new target list, preparing to have another go at Enceladus. They set the spacecraft on course for a set of close flybys of its south pole, down to as near as 25 miles above its surface. This is what Cassini saw: plumes of vapor rising out of the ice. Scientists began to think of them as geysers, much like those in geologic hotspots on Earth. If the Cassini team could find out just what these jets are made of, they might have some major clues to what's going on deep inside Enceladus. And if there truly is a liquid ocean, they might just find out what it's made of. To get some answers, Cassini sampled particles that make up the E-ring. It found crystals of water, and within them, it detected the presence of a simple compound well known on Earth: salt. Salt dissolved in water tastes like evidence to a scientist. Evidence that friction from a rocky core jostled by Saturn's gravity is warming a reservoir of liquid water below the icy surface of Enceladus and sending that water bursting through. Now, to be accurate, Enceladus jets could possibly form without liquid water. And even if they began as liquid, they may boil up out of a few water-filled caverns rather than a huge ocean. But if this tiny moon's waterspouts do originate in a sizable subterranean sea, the possibilities for life throughout the galaxy may be that much greater. How amazing! Almost 900 million miles from the Sun, far beyond the orbit of Earth, and far outside what many call the Goldilocks zone for living things, this distant little moon might just harbor the conditions needed for chemistry to become biology. And so we continue to mine the kingdom of Saturn for knowledge and images, and not just from space. For 8 years, astronomers at the Gemini North Telescope in Hawaii had been monitoring the infrared light streaming in from the Saturn system. Looking at Titan, they saw for the very first time evidence of a massive and unlikely storm erupting over what's thought to be a vast equatorial desert. If nothing else, it shows just how much we still have to learn about these mystery worlds. Meanwhile, Cassini kept adding to its unprecedented photographic collection. With Saturn now at its farthest point from the Sun, the angle of the light allows the Sun to cast long shadows across the rings. And out popped discoveries, like this little moon never before seen. Or these that seem to have punched right through the F-ring. We don't yet know if Saturn's moons have ignited the spark of life. But since the time of Galileo, they have certainly ignited our imaginations.